Hey guys, welcome back. We're going to take this RL series circuit up. Now, all the rules for series circuits are going to apply, and we just have to be a little bit careful about this because, you know, in level 1 or in DC circuits, the total resistance would be the sum of these two. In an AC circuit, we don't call it the total resistance anymore because there's resistance and then there's other things that limit current in the circuit. We call it the impedance. And the impedance is going to be the sum of all the gadgets in the circuit that limit current, okay? And the impedance, if you recall, its symbol is a Z and its unit is ohms. So I'm not going to write it down here, guys, but just remember that the impedance of a circuit is always the sum of all the gadgets in the circuit that limit current. So the very first thing it wants us to calculate here is the impedance of this circuit. What is the sum of all the gadgets that limit current in this circuit? Now, it'd be nice if it was 30 plus 45, but it's not because these guys are not in phase. And if I want to try to figure out what the impedance of this circuit is, I've got to use phasors, because this thing here will cause the current to be in phase, and this thing here will cause the current to lag by 90 degrees. And since this is a series circuit, guys, so we're going to draw our little phasor world here, and we're going to draw these phasors as they sit with respect to the current in the circuit. And so the first phasor I'm going to draw, guys, is going to be this 30 ohmer right here. It is a resistor, and a resistor is in phase. Okay, it's this guy right there. All right, and so I'm going to draw it as a line, 30 ohms long. There it is. This is going to be the resistor. It is 30 ohms. It is drawn in phase with the current. And then I'm going to draw XL, and XL is out of phase with the current by 90 degrees. It always will be. It causes the current to lag by 90 degrees, and so the only question is, do I have to draw it up here or do I have to draw it down here? And the answer to that is you must draw it up here. Now, a lot of students go, look, Van Andel, you said it lags. We know that lagging phasors are always drawn clockwise, but it doesn't lag. It causes the current to lag. So if I draw that 45 ohms right up here, XL is equal to 45 ohms, that is drawn so that the current is clockwise by 90 or the current is lagging by 90. All right, guys? And if we're going to do that, I got to move it tip to tail. Okay, so that's where it sits right there. And then the impedance is going to be the phasor sum of the two, guys. And so it is going to sit right here. All right, and this is going to be Z, and that's going to sit right in there. And the way to calculate, well, this is a nice right angle triangle, okay, which is fabulous. And since it's a nice right angle triangle, I can apply Pythagorean theorem to this, guys. So this is going to be 45 ohms. It's going to be XL. Okay, we've moved it from here. And Z, we're going to calculate it right here. It's going to be the square root of 30 squared plus 45 squared, okay, because of Pythagorean theorem. So let's see if we can figure that out here. 30 squared plus 45 squared equals, and then we'll take a square root of that, okay? It is 54.08, okay? 54.08 ohms. So, this is going to behave, one way to think about Z or impedance is it's like RT from level 1, okay? It's not RT, it's Z, okay? But it's like RT from level 1. It is the sum of all the devices in the circuit that are limiting current. And in this case, it's 54.08 ohms. Now that we know the sum of all the gadgets in the circuit that are limiting current, I should be able to calculate the current, because current is always going to be the voltage in the circuit divided by whatever's limiting current in the circuit. And in this case, that's impedance. And so it's going to be the 120 over 54.08. And we're going to calculate that. 120 divided by answer equals 2.219, okay? 2.219 amps. And that current will be flowing through both these devices. And just like in level 1, we just applied Ohm's law to the entire circuit. I can also apply it to individual components in the circuit. And so I'm going to use Ohm's law to calculate the drop there and also the voltage drop there. The voltage drop here is going to be EXL, and it is going to be I times XL. Okay, it is going to be the current through this gadget times the inductive reactance of that gadget. And so it's going to be 2.219 times 45 times 45. Looks like it's 99.85 volts. Okay, guys? And same thing with ER. It is going to be the current through that. So it's I times R. Okay, guys, so it's going to be 2.219 times 30, and we'll try that over here. 2.219 times 30 equals 66.57. Okay, guys, so we got those two voltage drops in this circuit. Now, with the other circuit, the level 1 circuit that we looked at, supposedly the sum of these two voltages is supposed to equal this volt. Well, I got 99.85 and 66.57. They don't appear to add up, but they actually do, because if I want to add those up, guys, I have to draw them as phasors. And so once again, I'm going to draw a little phasor world here. And we're going to draw these two voltages as phasors with respect to the current. Now this is the resistor. The resistor causes the voltage and the current to be in phase. So if I were to draw that voltage, it would sit right here. ER, it's 66.57 volts. And the other one, it would get drawn right here, drawn so that the current is clockwise or lagging by 90. So I'm going to draw it right there. This is going to be EXL, 99.85 volts. All right, guys. And the sum of the two is going to be a line that starts at the beginning of the first one and ends at the end of the last one, and it's going to be E total. And it should be equal to 99.85 plus 66.57. That's supposed to be a 6, okay? Squared, square root. So let's calculate that for a second just to see if we're on the right track here. 66.57 squared plus, 99.85 squared equals root equals 120 exactly, okay? 120 volts. So I'm trying to show you here that everything that we learned in level 1 about series circuits is going to apply to level 3 series circuits, 2 and 3. That is, there's one current in this circuit. The sum of these two is equal to that, but I must draw them as phasors. The phasor sum of all the gadgets that limit current in the circuit is going to be the impedance, okay, RT in quotes, all right? I can apply Ohm's law to the entire circuit. I can apply Ohm's law to the individual components in the circuit. The sum of the voltage drops is equal to the voltage rise, okay? The phasor sum of the voltage drops is equal to the voltage rise. Now there's one more thing we can calculate here, and that is the phase angle, because we know that the resistor causes the current to be in phase, and we know the inductor causes the current to lag by 90. So what about if I take the two components together? What's going on with the voltage and the current there? And I can actually see that phase angle right here, and I can calculate it down here. I've got this little phase angle symbol here. And I'm going to use my favorite. The tan of the angle is the opposite over the adjacent, which means the angle is equal to the opposite over the adjacent, inverse tan, which means it's opposite 99.85 if I use this triangle over the adjacent 66.57, tan to the -1. Now I could use this triangle too. It wouldn't make any difference. I could go 45 over 30 inverse tan, 99.85 over 66.57 inverse tan. It doesn't make any difference because these two angles are going to be identical. All right, guys? So use whatever phasor diagram you like to calculate the angle. So let's try that. 99.85 divided by 66.57 equals shift tan equals 56 degrees. Okay, 56.3 degrees. Now, what does that mean? Well, what it means is if I scope this individual component, guys, I would see the voltage and the current are in phase. If I scope this individual component, I would see the current is lagging by 90, okay? But what if I scope the entire circuit, okay, or both components? Well, what I would see is the voltage and the current are out of phase, and they're out of phase by 56.3 degrees, with the current lagging, which means this. If I scope this entire circuit, I would see the voltage, guys, like this, E. And then I would see the current. There's 90, okay? So lagging by 56 degrees. Let's see if I can draw this. Not too well, okay? So there's the current, lagging by 56 degrees. All right, guys? 56.3. That's just the way this circuit's going to work. All inductors are going to cause the current to lag. How much is it going to lag, Van Andel? Well, it's going to lag between 0 and 90 degrees, depending on, what's going on with these two components. That kind of thing. All right, guys? So let's put this in here, 56.3 degrees. And, well, your homework is going to be Unit 2, Handout 1. Okay, guys? Have a good day.